Okay, differentiation lesson 4. We're mostly going to be concentrating on notation today. Up until now, we've generally been using function notation. So a function of x is given by some expression in terms of x. To indicate the derivative, we're using f dash x. For a lot of cases, this is going to be really useful for us. There are some cases where we're not talking about x and y, we're maybe talking about different variables. And also sometimes we want to express what we're differentiating in a slightly different way, and then we're going to use Leibniz notation for this. Here we've got an example. Y is equal to 4x cubed minus 3x squared plus 6x. We're not given function notation, we're given y. So it's in terms of x and y. We could plot this on a graph. When I differentiate, I'm going to use the notation dy by dx. And we'll look at this in a little more detail when we're in class together. But essentially, the top part tells us what we're differentiating. So we're differentiating y. And the bottom part tells us with respect to what variable. In this case, we're differentiating y with respect to x. That means x is the number that's changing in this function, the independent variable if you like, and y is the variable that's affected by that change, so the dependent variable. So when we're given y equals, our derivative is dy by dx. We differentiate in exactly the same way. We multiply by the power, so 12x reduce the power by 1 squared, minus multiply by the power 6x reduce the power by 1 plus 6. These two types of notation came about because when calculus was first invented or discovered, it was done so independently by two different people. In the 17th century, Isaac Newton, who favoured the function notation, and Gottfried Leibniz, who this notation is named after. Now you'll find we will sometimes be using one and sometimes the other, and it depends on the circumstances which one is most useful and which one we'll be using. We need to be able to use both, so don't just decide that you prefer one. Depending on the question, you'll be expected to use the correct notation. Up until now, we've always really been looking at x and y, but when we differentiate, that's not necessarily the two variables that we're interested in comparing. In this case, I've got a p and I've got an f, so that means if I was to differentiate using my Leibniz notation, I'm going to say dp, because I'm differentiating p, by df, because I'm differentiating p with respect to f. Then I differentiate in the same way, multiply by the power 8f minus 3. So on the top it tells me I'm differentiating p, on the bottom it tells me with respect to f. Okay, let's look at the notes on page 6. So the first question asks us to differentiate 3t squared minus 2t with respect to t. Now, it tells us to differentiate with respect to t, but it's not given us an actual equation, so it's not equal to anything. So to differentiate, I'm just going to write d by dt, which means I'm differentiating with respect to t. I don't have a name for the variable, which we normally call y. We're going to differentiate as normal. 2 times 3 is 6, 6t, take away 2. For the second example, it's function notation. We have been told that a of r is equal to pi r squared. And we're asked to find a dash r. So we're differentiating this with respect to r. Now, it can be tempting to think you have to do something with pi here, but pi is just a number, so we'll do the normal, we'll multiply by the power and reduce the power by 1. So this will be 2 pi times r. example, we're asked to differentiate px squared with respect to p. Now, again, we're not given a full equation, something equals, so I'm just going to say I'm differentiating, and it's with respect to p. Now, we need to be a bit careful here. It's tempting to multiply by the power 2px, but that's with respect to x. We've got to assume that x is a constant and p is the variable in this case. So in that case, the derivative would simply be x squared, because x squared is just a number that's not going to change in this case. Let's just check you have the main points from today. So what are the two types of notation that we'll be using? And can you differentiate these expressions using the correct notation? Now, my concern is not can you differentiate at this point, it's are you using the correct notation? So do be careful and don't skip anything. Okay, we're now ready to look at exercise 6i. Questions 1 to 5. These are all unit level questions. All unit level questions.